Okay, so this is just like a little topic called inverse trig functions that show up, it seems like every other test on the AP test. Definitely on the BC exam, but on AB just once in a while. So if you go back to when you were in trig, if you had a problem like this, sine x equals 42, you had to figure out what x was. So on your calculator, you would use a key called sine inverse, and then you would say sine inverse of 42, and that would get you back to x. Okay, that's what we're talking about when we're talking about inverse. And I just want to mention, if for something like sine inverse of x, you may also see it as arc tan x. And in the instructions for the AP exam, they'll say that the inverse function may be described as arctan. So if you see arctan x, that would mean tan inverse x. If you see arc sine x, that means it's sine inverse x. Okay? All right. So, start off kind of easy. So let's say that they ask you to find the derivative of sine inverse of u, whatever u is. Okay, the derivative of that would be 1 over radical 1 minus u squared, and then times the derivative of u. So that's always what it's going to be when it's sine inverse. So these are just things you have to memorize. This is why I always save it for the end. So let's say it was asking for the derivative of sine inverse of x squared. Okay, so that would equal 1 over the square root of 1 minus u is x squared, so x squared squared times the derivative of u, which would be 2x. Okay, that's how you would use it. So I'm just going to give you all the different derivatives so that you have one for sine. The derivative of cosine inverse u is negative 1 over radical 1 minus u squared times u prime. So the difference between that and sine is that this one has a negative in the numerator. The derivative of tan inverse u is 1 over 1 plus u squared times the derivative of u. In my experience, I have found that tan is the most popular one that they will use. For cotan, not very popular at all. It's negative 1 over 1 plus u squared times the derivative of u. For secant, it's 1 over absolute value of u, square root of u squared minus 1 times the derivative of u. And finally, the derivative of cosecant is negative 1 over absolute value of u, radical u squared minus 1 times the derivative of u, which looks just like the secant inverse, except that it has a negative in the numerator. So this is just really way too much for you to memorize, and I would say definitely know the tan inverse one, and if you could do sine and cosine, but I mean, this is what they all are. All right, so I'm just going to give you another example. So let's say you had to find the derivative of secant inverse of x squared minus x. So for secant, the answer would be 1 over absolute value of u. So the u is just the inside, right? X squared minus x. So absolute value of x squared minus x, radical u squared minus 1 times the derivative of u, which would just be 2x minus 1. Okay, so it's rarely tested, but I just felt like you should know that. Okay, and the opposite of that would be the integral, right? So if you have something that looks like this, there's no way you could solve that, just regularly, but that does look like 1 over radical 1 minus u squared. This would be sine inverse u plus c. So I'm just going backwards. Or let's say you had du over 1 plus u squared that would be tan inverse u plus c, etc. So you would just work backwards. So let me give you an example. So let's say you had this. Okay, I just want to say it is highly unlikely that you're going to see this, but I just wanted you to see an example. Okay, so this is nothing that you're going to be able to solve, but you might notice that looks something like a 1 minus u squared, but only it's to the fourth. So this would require u substitution. So we're going to say u is x squared. Okay, why x squared? Because we're looking at this x to the fourth, and we want to take the square root of that, so x squared. Okay, so du is going to be 2x dx. So if you look at the original, we have an x and a dx, but we don't have a 2. So we're going to divide both sides by 2. And now we're going to substitute. So we're going to take out this x dx. We're going to replace it with 1/2 du. Okay, we're left with a 1 on the top. We still have the radical on the bottom. And we have 1 minus x to the fourth, which would be 1 minus u squared. Okay, where did I get that from? Because 1 minus x to the fourth, x squared is equal to u. So this x to the fourth, I can just change that to a u squared. That's where that came from. Okay, and so this will give me 1/2, and now I'm going to do this integral, and you should notice that is going to be a sine inverse. So sine inverse of u squared plus c, but we're not really looking for u, we're looking for x. So we have 1/2 sine inverse x squared plus c. That would be the answer. So highly unlikely to get anything that complicated. If anything, you'll probably see this one. That's the most popular of them all. But I just wanted to make sure you did see these problems. Okay, that's it.